In this video, we will look at creating replication jobs. We have already seen how to set up replication services at multiple sites. We have also seen how to set up replication targets. And now is the time to actually leverage that work and create the replication jobs that will do all the hard work for us. So now we are at our branch site 2, which has the vCenter 221. This is part of the linked mode group with 220 at headquarters. And we see a couple of interesting virtual machines here called packed pub 1 and packed pub 2. Let's select packed pub 2 and see how we can configure replication. So I right click on this, and at the bottom I have all vSphere replication actions. The only action right now is configure replication. So I click on configure replication. It asks me whether I need to replicate to a vCenter server or to replicate to a cloud provider. Now if we had already set up a target to a cloud provider such as vCloud Air, as I showed in a previous video, we could have selected this option as well. But if I click this obviously and hit next, there are no targets, so nothing will happen. So I will reselect replicate to a vCenter server. I click next. Now the connections are to a vCenter on 223, which is branch 3, and obviously it is connected to itself as well, and then to 220 as well, which is at headquarters. So I want to send this replication over to headquarters. Remember, I'm at the branch, so I need to send this to headquarters. So I'm sending this to headquarters. And so I click on the headquarters vCenter, and we auto assign the replication server. And now we need to select a data store where the replicated files will be stored. So this set of data stores will exist on the target site that we selected. So I click on edit, and I see the various data stores available are these. I have a cluster already set up which is called the packed data store cluster. When I click on that, it actually gives me the two different data stores that make up that data store cluster, data store 200GB and data store 200GA. Each are 200 gig, and it's just A and B. So I will select data store 200GA, and what it tells me is that the replicated files will be stored in this folder and will be stored on data store 200GA. It gives me all the other stuff that's out there as well. I click on OK, and just review that. Our target VM location is data store 200GA packed pub 2. Okay, I click next. Now I have some replication options. So let's look at these. The guest OS quiescing. What it does is it basically quiesces the file system so that if there's any outstanding I/O, it is quiesced. And that obviously takes some time for it to happen. So it does affect the RPO time, which is the recovery point objective time. Now this is a Ubuntu machine. I don't know how we're going to set up quiescing on this. But if this was a Windows machine, we could have used the volume shadow copy as an example to quiesce that. So there are ways of quiescing the guest OS, but again, the issue really is that it takes a long time for the I/O to be completed and for that guest OS to be in a quiesced state, and this affects RPO times. Most cases, the vSphere API for data protection, which is VADP, will basically take snapshots, and you will get basically your replication that is consistent for that snapshot. Another option that's available with is called a network compression, so that the data that's sent across the network is actually compressed, and while it consumes more CPU resources, it is much faster because over the network, but then it has to be decompressed on the other side as well. Now, this is only actually possible if both sides are vSphere 6. It is only then that you are able to do end-to-end compression. If you have, for example, vSphere 6 and a vSphere 5 replication set up, compression will not be possible. It's only vSphere 6 and above that compression is possible. Also, what happens is that if you have ESXi servers that are both the source and target are ESXi version 6, but the data store is a version 5.5 or ESXi 5 or less data store, then that compression doesn't go down all the way to the end, and much decompression has to be done in the receiving replication server. So in our case, we have vSphere 6 running at both ends, and all our data stores are version 6 data stores. So I will enable compression, network compression for the data. I click on next, And now we have to look at the recovery settings. So the key here is the recovery point objective, which can be from 15 minutes at the lowest to 24 hours at the most. Now 5 minutes RPO is supported under special conditions. We can click learn more. It's basically for vSAN. So we can, if the target and source sites use virtual vSAN, and so this 5-minute RPO setting is displayed only when the target and the source use virtual vSANs. Now I'm not using virtual vSAN, so the least that it shows me is 15 minutes. Now what does recovery point objective mean? It means that if it's set to 4 hours, then the replication guarantees that the most data that you will ever lose from the source system in case of recovery is worth 4 hours of uptime. So obviously one tries to make this as less as possible, so that at the very most you like to lose 15 minutes of data. But then that also means that replications have to happen more frequently. So if I make it 15 minutes, that means that a replication that takes 4 minutes has to happen at least every 11 minutes. Otherwise my recovery point objective will not be met. And the replication manager takes care of that, and actually if there are RPO violations, they show up on the reporting that is available with this product. Now the issue is this. Suppose I set the RPO to 15 minutes and it takes 4 minutes for the replication to actually happen, because the amount of changes on the source virtual machine are quite extensive. But if it takes, so every 11 minutes is when the data has to be transferred across. But of course if there's a glitch in that, or there's more traffic and it takes more than 11 minutes, then your recovery point objective has not been met. So one has to be very careful with it, and obviously this is a business consideration. The actual time should not automatically be made 15 minutes, the RPO. It should be dependent on the kind of recovery that you actually need. And depending on that, you then have to monitor your replications, make sure they are all happening with enough leeway in your bandwidth, so that your bandwidth is not a constraining factor. You may need more bandwidth if you keep your recovery point objective very, very low, because the replication has to happen more often, and if there are a lot of changes, then the data that has to be sent across is extremely high. So the point I was making before is that if you set it to 15 minutes and it takes about 4 minutes for the data to get across, that means the replication has to be renewed every 11 minutes. But the problem is, if there is a sudden surge in the amount of data that has changed in your source machine, all those changes may not be possible to be sent across in that remaining time, and you would have a recovery point objective violation. The point in instance is very, very useful. The only issue is if you have enough storage for it, then it's perfect. So retained replication instances are converted to snapshots during recovery, and you cannot replicate existing VM snapshots basically. So you need to be sure that you're running snapshot free. Now they're converted to snapshots only when you actually do a recovery, but you can retain point-in-time instances. So if I enable this, okay, the default here is that I keep 3 instances per day for the last 5 days for a total of 15. Now the maximum number of these instances is 24. So the multiplication factor between 3, if you multiply 3 by 5, it's 15. That's okay. But if I make it 8, then it becomes 27, which is more than 24, which is the limit. And so you get total number of retained instances cannot exceed 24. I like to keep this right now at 3 instances for the last 5 days. Now if the RPO is more than 8 hours, you may want to decrease the RPO value to being something less, so that vSphere application creates the number of instances that you actually want to keep. Because remember, 3 instances per day means every 8 hours you want to keep a point-in-time instance. Okay, I like to keep point-in-time instances because I have enough storage. When I click on next, since the virtual machine is not powered on, replication will start when the virtual machine is powered on. Apart from that, we are replicating to our headquarters site. The replication server will be auto-assigned. We have the target location to data store 200G-A. There's only one disk in this virtual machine. There are no disk seeds. What disk seeds means is that if you have a very large virtual disk, VMDKs, then you can actually pre-populate the VMDKs on the receiving replication server. And then when you actually define your replication and you point to that data store, the replication mechanism actually looks to see if there are VMDKs with the right name for that virtual machine. And if they are there, then it basically says that those seeds are available. Now, obviously, the advantage of this is that the very first time you start up a virtual machine, the entire VMDK has to be replicated across. If this is a very large virtual machine, then it'll take a very long time, and you will probably lose your recovery point objective constraints right there and have violations. So for large systems, and especially if you are replicating to a cloud system like vCloud Air, it is best to copy the VMDKs, send them over, have VMware actually restore them on the other side, and then use them as seed VMDKs, which the replication mechanism recognizes when you actually define a new replication job. And with that, we say finish, and it is in the process of creating a new replication job. So when we go back to the vCenter and we go back to monitor vSphere replication, we see that in the outgoing replication, this has been added and it is not active at this point in time. The virtual machine has not been powered up. Let's look at our headquarters site and look at incoming replications. You can see that that replication has been represented there. I have now powered on the virtual machine, and when I refresh, I get the status of OK. And you can see what happened here. The last sync happened just a few seconds ago. It took 19 seconds, and the entire VMDK was moved across, and it was 226.96 megabytes, and the RPO is this. If you look at the point in time, well, that is our very first sync point that is available on the receiving server. Okay, now let's look at some of these icons. This icon pauses the ongoing replication. This permanently stops the replication. This one does a sync now. So that means it synchronizes at the moment this is pressed, and that's what we're going to do at this point in time. It is now doing the replication. It took about 30 seconds elapsed time to update the information up here, but you can see that it changed. The last sync duration was only 1 second because there was not much to be changed, I guess. And the last sync size was 168 KB, which was much smaller than the initial sizing. So let's see if we have more sync points available, and the answer is yes, we have more sync points available. So why this is really important is that if we had made any changes between this time here and this time here, we have the ability to recover to the initial synchronization point. Obviously, it's a huge benefit to be able to do that, and obviously this is extremely simple to set up and use. As we've seen, vSphere replication servers on both sides, vCenter servers on both sides that are actually managing those replication managers and servers, and then you go in virtual machine by virtual machine is one way to do it. Or you can actually, if you have multiple virtual machines, you can shift click or you can control click the ones that you need and set up replication jobs all at once. You can also pick up entire folders, and you can pick up entire clusters of virtual machines in host clusters as well. So you don't always have to do it one by one. But from a learning perspective, this is the way it works. You can, like I said, you can group them by multi-clicking or multi-selecting the virtual machines, and then you can easily create those jobs. I believe I read somewhere it is recommended that not more than 30 virtual machines be selected at once because otherwise it takes a really long time for the replication jobs to be set up, because really 30 different things have to be done by the two servers on the source and the target side. But be that as it may, it is a very simple thing to use and very simple to set up. In the next video, we will cover recovering replicated virtual machines, since we have already started the process of replicating virtual machines to different sites. In the case of a disaster, we now will need to understand how to recover these same replicated virtual machines. I look forward to seeing you on the next video.